Welcome, Chapter 6, Electronic Elements, a detailed discussion. We're going to look at all the different electronics, closed, caption, digital video, wireless, security communication, systems commands, workstations, servers, a little of everything in this chapter on how everything comes together. So this chapter will discuss the design elements for alarm access control, system servers, workstation, advanced elements, closed coast TV, digital video, communications, consoles, servers. So everything that we've been touching on, we're going to kind of give it an overview. So this is everything we're going to look at. The alarm system, servers, caption TV, console guards, a little of everything that we've been looking at. Let's get a look. Identification devices, magnetic strips. So identification devices include cards, keys, barcodes, radio frequency readers, keypads, biometric readers, access to control. So it's a little of everything, as we're going to get into. The most basic type of ID is just a keypad. You got to put in a code, simple, inexpensive. It stays on the door. Only theoretically, the people who need it have it. If you don't need to get in, you don't know the number. So, it is a form of security that helps prevent people from entering restricted areas. They work quite well, but again, the problem with them, people can easily give out the number to people who shouldn't have it, so then that becomes a problem. So that is the one downside of just a basic device, a key code. Let's see, simple. You can actually even give it, right now with Wi-Fi, you can actually give the UPS driver, if your area has it, access to your garage door opener, and they can get in that way and put your device, your package in there. So these are some of the different things that we have. Let's see, what else? There's different kinds of devices, but basically the keypad is a simple way to set it up. Key cards, barcode scanners, same type of thing. You can actually give someone that barcode so they can get in that way. Barium ferrite cards, holorith, and rare earth magnets are all simple ways that we can lock up our system. Having a photo ID is also a really good idea. It helps prevent, obviously the generic thief from getting in, so you got to have an ID, which is a great way to go. Let's see, smart barcodes, magnetic strip readers, is that what we're covering? Yeah, magnetic strip readers that we had. We go to effects, the name discovery. Effect occurs when specific made to wire is moved past a wire strip, causing it to emit. That's the WeGAN card. Again, there's a little wire in it. In their keys to prevent things, similar to what your car has. Barcode readers use the several barcode scans. Again, you've got to have the barcode, the right scanner. Barium ferrite cards used similar to magnetic materials, similar to as a magnetic code. Material is essential permanent magnet, very robust. Insert swipe for swipe type. These are often the form of aluminum plate within it with beveled in. Holorith, based on the punch code cards by Sam Holorith, inventor IBM. The Holorith card was the way programming was done years ago. The rare earth, extremely rare access. Rare earth key. The rare earth magnets are set to a pattern of 4 wide by 8 long in each position north-south. North pointing left to right, making a pattern of ones and zeros. Photo cards, again, having the photo, someone can see who you are in order to let you in. Multi-technology cards is common for some employees to need to travel to multiple sites in the office. So one solution is carry different cards, which can be annoying. Card readers, nice and simple. You wave the card, you have an ID in it to make sure you have it. You can have proximity cards also, so you just have to be close. You can have the swipe. You know, you see these are like on subways. You can actually have that swipe material. Let's see. TWIC cards. They are the Transportation Security Agency, TSA, has implemented the Transportation Worker Identification Credential. And this means you are all put in a system, you're verified who you are, so it's for getting on docks, usually transportation. It usually includes a photo, a biometric credential. So it's really a high security, simple card that you have to be on there. Biometric readers come in many different forms, mostly finger, to allow you in. Other field devices include electrified locks, door position switches, request to exit devices, and gate. Again, all these devices are limiting the flow of people to secure areas, making sure that they are safe. Electrified strikes replaces conventional door strikes into which a typical door latches. Unlike conventional doors, which require the door to be latched to be retracted for it to open, electrified strike unlocks the door by simply folding back the release of the door and swings back instantly. And again, if you're doing, like I know at one of the campuses I work at, they have electrified doors. At 8 o'clock at night, they all lock. At 7 o'clock in the morning, they all unlock. So it makes it easy to maintain who's going in and out of it. The mortise lock is a lock that is built into a routed pocket or mortise. These locks are very strong because the lock is sizable relative to the latch of the deadbolt. Again, same type of thing. It's electric, so we can see it. Magnetic locks, often considered the staple of electrified locks. The magnet lock is a little more than just an electromatic attached to the door and the armature attached to the door. When magnetic is energized and the aperture is against it, it usually opens. The electrified panic hardware is where the door is located in the path of egress. Panic hardware is often used depending on the occupancy rating. Panic hardware is required on any door where there could be a large number of people needing to exit quickly. Panic hardware is easily identified by a push bar, formerly called a crash bar. Specialty locks. Attention to door locks, they must use them. However, there are a remarkable number of variations. Doors, frames, electrified, some unusual locks have been developed for special needs. Switches, doors and gates, DPS switches. Sense the door or the gate is open or closed, and it allows us to get in and out with that. A door switch are usually placed under the desk or counter to alert security if a person at the counter feels threatened. The two most common are finger activated or foot. So if you think about a bank, if they're getting robbed, they can press a button to alert police. And then we also have the request for exit. So you come in, the door locks behind you. In order to get out, you must request to get out of the button. And again, it's usually electronic lock. So when the button is pressed, the person can then leave the building. Again, these are ways to help secure the room, the building, to ensure everyone inside is safe, the material is safe. Door and gate operators automatically close in response to the command of the door. Door operators are common in public buildings, assist in the movement of a large number of people. Revolving doors, turnstiles. These are some of the different things that you'll have going on. Turnstiles can have card readers, remote bypass, auto reverse if two or more people enter, auto reverse for unauthorized people, auto alert for improper use. These are all the different options that we have. And usually the turnstiles electronic processing component includes some kind of card reader so people can see what's going on, alarm system to make it easy to use. Servers and business continuity servers. An enterprise class alarm and access control system depends on servers to store and manage master databases. Smaller systems may incorporate servers and functions directly into the system's workstation. Servers operate basically two kinds: system operations and archiving. Larger system, it's common to have built-in backup every night to ensure everything backed up is either by mirror or failover. Server racks are usually locked in a secure room. Workstations. Workstations allow humans to interface with the communications with the servers, with the entire system. On the system's design, corporate headquarters allow people to have workstations and cameras so you can see what's going on all the systems. Data infrastructure. When a user presents a card to a card reader and the card reader passes the information to the controller, decisions made to unlock the door. So this is, when we're working with the system, if the card reader is not working, the person at the workstation can fix it, make sure that they're on the list. It's usually a communication with the network, allowing everything to connect, so whoever's coming in and out of the building, if someone sitting at a workstation can actually read the information to ensure that the correct people are there. Interfaces in other buildings. Typically interfaces include fire alarm systems, elevators, parking systems, signage, private automated branch exchange systems, paging systems. So the interface of the building is everything is built in. Again, all this can be operated from a workstation, which is usually connected to the servers that we saw before. And this allows us to have continuity on what's going on. Legacy systems. These are the old infrastructures in the 70s, 80s, 90s, and even into 2000s where we'd have our servers in a room, some of them even dating in the 50s with the punch cards. But the legacy systems have been around for 40, 50 years. Large companies still might be retaining some data on them, but for the most part, they haven't been used much. The government probably will still have a few in production, only because of the amount of data that they have on them. Again, this is other issues that we might have because of the age of everything and becoming older. Data versus hardware interfaces. Alarms and access control systems are often interfaced to other buildings, such as elevators and buildings automation systems. Data interfaces have advantages. Single data interface can last a lifetime, no matter how many times it's used. Second, the single wire control empire. Once the interface is conducted on the networks, it is global, so we can see what's going on. let's see. That's the same thing. Closed circuit TV and digital video systems. At the time, there was a video cameras were everywhere in the security system, making sure it recorded everything back to the main system. At the time, having a camera was a high end. Only the most sophisticated systems would have it. Today, as you know, you get a Ring doorbell for under $100, and it basically does the same thing that the camera systems did in the 50s, with even more accuracy. And today, with the digital, everything being digital, recording is much easier. Let's see. Philo Farnsworth, who worked for Thomas Edison, who invented the system, allowed us to have this with the vacuum tubes, and today everything is now digital. The analog is capturing that video. Like I said, from when Thomas Edison, it basically was black and white. And the basic TV with the huge screen in the back. Let's see, what's the branch? Video evolution took a branch that is still continued today. Device called the Quad. This device displays 4 video cameras on a single screen, recording them onto a single tape. This allowed us to record and see what was happening on 4 screens at the same time. Videotape was at the time, that was during the 70s, 80s, and 90s. The VHS tape would be able to record up to 6 hours, then it would overwrite itself. Again, recording it on videotapes. Literally, the problem with it, the major problem is the videotape would actually break, or being written over so much that it would become very grainy and very difficult to read or to see what was going on. So that became a problem. And then once digital came around, scanning, capturing the displays was much easier, much clearer, didn't require as much space, and it allowed us to capture everything. Capturing displays in digital thing. Captures it entire. Light focused on the lens allowed us to have it recorded onto the chips. And this led us to the LCD, the liquid display, and digital light processor, the DLP. And as you know, we use LCDs are very common for our displays that we use. Analog video is transmitting as a fluctuating voltage with codes embedded for color, hue, and gamma. This fluctuation voltage can be fed into a recording head, and the basic recording analog head converted. Again, anything that was recorded on tape has the problem of it being deteriorating over time. So converting everything to digital is becoming much more common. The digital basics, digital video, it uses it's switch packaging, TCP. You might have heard TCP/IP, and it basically is using the same type of thing, transmission control protocol, and it breaks it up into small packets. As it sends it over the network, it allows it to figure out how many packets it is. When it sends it, it says it's a packet of 5 of 6, and if all 6 don't show up, it can send for a resend. So it works much better. It's actually how our current telephone systems work, our computer systems. Everything uses the TCP/IP protocol, which enables us to transmit digitally, breaking it into small packets, usually groups of 8 bits, so it can basically communicate over at the speed of light. The internet, ARPANET, was built in the 1950s. It is known as the internet today. And ARPANET is, like we said, at the time there was 4 colleges on it: MIT, Southern California, and I believe one in Chicago. And that developed into the TCP/IP protocol, VLANs, VPN, IPv6 were up to 6 brackets instead of just the 4. Wireless. Let's take a look at wireless. As you know, everything runs through wires in your server room. Everything is wires. The last 100 yards is wireless. It allows us to connect, but it is very limited. It is slow. But almost everything is wireless. Your laptop has wireless communications on it. Your Ring doorbell, your cameras, your Nest cameras, everything has gone wireless. And that's because it allows the flexibility. Prior to wireless, wires had to be run, which we'll talk about in a second. But the wireless has many standards. The first, the laser, although it's becoming difficult to find laser transmitters and receivers. They have line of sight. Video transmitters are immune to radio frequencies. Microwave wireless, again, line of sight. They have to be applied. The microwave can see, typically distance of 20 miles. Bidirectional. It can get through any weather. And it allows it. And the radio frequency, as you know, that's been around. And basically the radio frequency just transmits out to everyone. The different frequencies, FM is 400, FM TV. Digital is 1.2 gigahertz. And we're up to 10 gigahertz for digital transmission. Analog, basically it's your voice being sent over the phone wires, and it uses the sine waves to track what you are in frequency on what we can send. That's the UHF analog. Again, very limited on what it can do and what it can send. Digital uses the TCP/IP or UDP/IP signals over the air. They're very limited in how far they can travel. Frequency, radio frequency is 2.4, 5.0, 5.8, and 10 to 24 gigahertz. These are some of the faster ones. Most standards, general standards, the 802.11, A, B, G, or I, do not require licenses as others do. Let's see. Satellites. As this becomes more common, satellites, transmission used to either portable fixed satellite or upload or download. The Royal Air Force Electronics in Britain, the problem with satellites is the positioning of it, precise positioning, weather interference, latency delays, and exceeding 240 milliseconds to experience everything on it. As you know, satellite phones are becoming more popular. With StarNet, satellite phones can be used to transmit video. Unlike satellite dishes, no precise positioning is required. Simply turn it on and it picks it up. The latency problems is satellites insert very high latency, typically more than 240 milliseconds. This It's useful to pan, tilt, and other insert delays, making voice communication tricky. However, it cannot communicate for offshore oil platforms when connection to alarm systems allows what's happening going on. Wireless architecture. As we start looking point-to-point, wireless just goes from one point to the next, 2 nodes, that does the connection for us. Point to multi-point connections. One point can send out to multiple connections, and we have mesh, and that sends out to everyone. Full duplex wireless mesh is sending it to everything redundantly, ensuring that the network is up. This is the most expensive. Point-to-point is the cheapest, going up in price till we get up to the full duplex. Full duplex wireless mesh is the most secure in the fact that it's never going to go down because every point can transmit to every other point. It is also all bi-directional. Video analytics, fixed algorithms is a technology. Video analytics is the process of digital video signals using a special algorithm to perform security-related fixed algorithm, artificial intelligence, facial recognition. These are the things that we're going to take a look at. Lenses and lighting level. Lenses are to the video what loudspeakers to the audio system. Just as there is dramatic difference in quality of audio, it depends on the level of the sensors for the video image. And as you know, we've seen that with technology change over the last couple of years, our smartphones have some of the greatest camera systems that we have that allow us to have good video. Even our doorbells, our Nest cameras. 10 years ago, none of this was available, but because of technology changing so fast with cameras and lighting, we're able to get all this technology out. The contrast, again, we talked about this in Chapter 5, lighting contrast. Can we see in the dark? What can we see? How is the color that we look at? Lighting, color, and temperature is measured in kelvins. Spectrum of red to high as we move along. Appears in yellow as the temperature is lower, yellow to blue, so we can see what's going on. LED lamps. Security communications. How do we communicate? Two-way radios, communication between security officers and public. Why do we want to make sure the communication works? Because there's a problem, we need to communicate between security officers and other securities. Two-way radios provide a constant connection as long as everyone's on the same frequency. There's a bunch of frequencies so they can communicate at all times to ensure that the network is up. We're not requiring on another network. Cell phones is an inexpensive way to communicate. However, if the telephone network goes down, communication can be lost. So we need to make sure that doesn't happen. Intercoms are usually enabled for someone to talk over a field intercom, ensuring that the people can be heard, calling out stations where they are. Emergency phones are intercoms that are equipped with flashing lights and strobes to help the responders find who's calling. And then the paging system, again, is the communication console over the field. Intercoms and voice. Historically used analog communications. That's a microphone was connected to an amplifier and a speaker. For larger systems, the matrix switcher was used to manage one of a few consoles. Systems also use circuit switch networks. Each circuit can carry only one communication at a time, sending it over. Drawbacks, wiring, fixed architecture, we have to have it in. When we switch to digital systems, the network, how do we maintain a circuit from New York to California? The cost of leased lines is too high, so digital intercoms are used to put it around. With digital, you can have multiple signals sent out over the same wire. And then the digital also works well with wireless. As we start sending wireless communication, this enables it to be remotely in emergency phones to the landline. And the system, two-way radios, cell phones, lenses, everything is communication to one console. And this makes it easier for tracking of what's going on, so everyone has the same information at all times. Command, control, and communication consoles and workstations provide a means to instruct the security system on how to behave and interact with its environment, and use it to provide face for security systems in that. Single-site systems are often designed with common workstations that will provide all system services together in a single computer, allowing easy to control. Medium-sized systems will typically incorporate a higher level of systems integration and possibly more than one workstation or console. And the enterprise system is a complete system that has everything built into it. Command, control, and communication consoles are C3. This is the heart of the operation. Everyone has this. Enterprise class alarm monitoring management systems, usually having more than one console. Spread throughout the area to ensure that everything is up and running and everyone knows what's going on. In case of emergency, hurricanes, fires, these really become the heart of who's doing what, coordination of everything. These are usually high-end systems that allow us to have everything on there. The C3 console are particularly used for mass transit facilities where the responding officers needs to control where everyone is. Lobby desks, again, security workstations are often placed in a lobby desk where people can come and ask for assistance and figure out what's going on. Dispatch consoles, usually workstations, again, computer aided, to make sure that they can send out what needs to be done, train stations, facilities. Administration workstations facilitate the programming of cards, where you might have to go and get your identification. Your identification badge consoles will have specific software. They take the photo of it, put it on the card, link it to your RFID or whatever's on the back, your strip, so it knows who you are at all times. And let's see what else. Guard consoles, vetting alarms, granting access remotely, video surveillance, video guard tours, video pursuit, building systems interface. Vetting is making sure that anyone in the security system will report to guard console. The console software should be integrated with everything that we have going on. Granting access is another function. Remote granting to ensure typical allows everything to have. And let's see, video surveillance. Security system intercoms provide a convenient way for visitors to gain information or access at remote doors. Again, having the intercom system, elevator and parking intercoms. Again, if there's someone stuck in the elevator, they're able to communicate. Emergency call stations are equipped throughout the campus, so people know where to go if they have a problem. They press the button, there's someone always there. You can have direct ring intercoms that allow the connection of everything. Two-way radios, again, for people having their pagers, allow you to connect to someone instantaneously. Wireless headsets, and so all this. In the summer, we had access control, other devices, integrated security, analog versus digital, video analytics, security, and communication.